Hello friends, welcome to bankaspirants.com. In this video, we are going to see an interesting and important topic in bank exams aspect. So it is nothing but syllogism. We are going to cover from the basics, and those who are very new to this topic, it will be very useful for you because it is a very important topic and there will be definitely 3 to 5 questions asked in every exams. Okay. And here some rules are followed in syllogisms. We are going to discuss that in this video, and also we are going to solve some examples related to it. Okay, let's move to rules. Rule number 1. All A is B and all B is A. So here we are going to solve all these examples with the Venn diagram representation. We have all learned Venn diagram representation in our childhood days. Okay, so we all know how to represent, how to use Venn diagrams. So we are going to solve these examples using that Venn diagram only. So let's see how to draw a diagram for this. All A is B and all B is A. So first of all A is B. So all A is inside B. So it is nothing but from the question itself it is very easy. So we are going to draw a circle for A and we are going to cover it with B. That's all. So this is all A is B and all B is same. All B is A. Okay. This is rule number 1. So these are the rules first of all for the from the basic we are solving. So we have to know all this. All A is B and all B is A. Rule number 2. Sum A is B and so sum A is B here given. Sum A is B means what? Only some part of the A and B is intersected. So we are drawing diagram like sum A and B is intersected, and similarly sum B is A. So some part of B and A is intersected. Only the variables are changing. Okay, and there may be some other variables given in the place of A and B. For example, some cats or dogs, or some dogs or horses. So the same diagram representation only for whatever variable given in the question. So this is nothing but rules. If you know these rules, it will be very easy for you to solve. Okay, rule number 3. No A is B and no B is A. Here what it is given? No A is B. So no relationship between. So no representation means no relationship between A and B. So there is draw a circle for A and draw a circle for B, and there is no relationship between A and B. Then how to indicate that? Just to draw a line and mark it as into. That's all. That's the just a cross mark. Okay, and no B is A. Same. Rule number 4. Some A's are not B and some B's are not A. So here some A's are not B is given. So how you will draw? The intersected part also not belongs to A. Sorry, not belongs to B. So only the A part alone belongs to A. Some A's are not B. Okay. Similarly, some B's are not A. Only the B part alone belongs to B. And the intersected part also not belongs to A. Not belongs to B. Sorry. Some B's are not A. So only we are drawing like this. So these 4 rules are the very basic rules, friends. So you have to know this. Next, we'll go for rule number 5. See here, 2 statements are given. So far we have seen only one statement. So from this slide we are going to see 2 statements, and also we are going to see conclusions. We are going to derive conclusion based on the diagram. In the exam, you will be given with the statements and conclusions, and you have to draw a diagram and you have to check whether the conclusion is right or wrong. This is what syllogism is. So see the statement what it is given. All A is B, some B is C. So we all know how to draw diagrams for this statement. So all A is B. What will be drawing? First draw a diagram for A and B, and you have to intersect B with C. That's all. So see, all A is B, some B is C. Okay. See, in conclusion, what we can derive from this diagram. Some B's are A. In the diagram and then also in the question, it is given all A is B. But only some part of B is inside A. Only some part of B contains A. And some part of B contains C. And some part of B is itself B. So only some B's are A and some C's are B. And we cannot, question itself, we know some B is C. So some C's are B. But here you can't write all B is A. Why we can't write all B is A? Because only some part of B contains A and some part of B contains C. Not every B is inside A. Only A is inside B. So, from the diagram and from the question, it is very clear that all A is B. Only A is inside B and some B part alone belongs to A. Okay, so this is the two conclusions for this diagram. So now, possibility condition. It is a very important topic in syllogism. Possibility conditions, you will be getting some questions, 2 or 3 questions. So let us know first what is a possibility condition. Okay. Negative conclusion or no case conclusion related with statements. You are given with some statements now, and also in the conclusion, if you are given with negative conclusions or no case conclusions, for example, an illusion conclusion or a hypothetical conclusion. Okay. So that type of conclusions are called possibility conclusions. That may not be real, but that may be an assumption. That may be an assumption. So that conditions are called as possibility conditions. So the possibility conclusions contains some keywords. So what are the keywords? Can be, can never be, may be, is be. So these 4 keywords are related with possibility conclusions. If you are given conclusions with following this keywords now, then it is a possibility conclusion. If statement is 100% true, then conclusion cannot be 100% false. If you are given with some statement, 100% true statement is given, and conclusion, if it is given 100% false conclusion is given, then we can't say the conclusion is 100% false, because there can also be a possibility. That is what they are saying. That can also be an illusion. We can have an illustration diagram, and we can say it is possible. So that is the possibility condition. We have to check for the possibility condition only when we are given these keywords in the conclusion. Okay, these keywords related conclusions are given in the question. Then we have to check for possibility condition. So what are the keywords? 4 keywords, important keywords are can be, can never be, may be, is be. Okay, do you get this? Okay, let's move to the rules now. Possibility rules. See, rule 6 with possibility. Statement, some A or B. So we are going to draw a diagram with some A or B. Only some part of A and B are intersected. So now we are going to see what are the conclusions, what are the possible conditions for this diagram. Okay, so these are the possible conditions. See, now let's see what are they. Some A or B is a possibility. It is already given in the question itself. And some B or A is a possibility. Some A or not B is also a possibility. And some B or not A is also a possibility. Because only some part of A and B are intersected. So we can also say some A and some B or not belongs to A and B. And also we can say all A or B is a possibility and all B or A is a possibility. Okay. So only if it is given a possibility or some keywords are given in the conclusions, then only we have to check for possibility conclusions. Okay. So these are the conclusions related for that statement. Okay. Let's move to rule number 7. all A is B and no B is C. The similar diagram only we are going to draw for this also. Only in the conclusion it will be differ. Possibility will be added or some keywords related with possibility will be given. Okay, so the statement is all A is B and no B is C. So draw a diagram for all A is B and no B is C. There is no relationship between B and C. So in the conclusion, what we are getting, some B's are A. So we know some B's are A, but no, there is no possibility given. See, there is no possibility given. It is a general statement, general conclusion. Some B's are A. It is definitely correct. All A is B means some B's are A. It is definitely correct. And all B's or being A is a possibility. All B's or being A is a possibility. Yes, it is a possibility. Because in the question, we have given only all A is B. There is some relationship between A and B. But all B's or being A is also a possibility. So it is definitely true. The second conclusion also definitely comes true. Okay. And for example, now let me ask some question. Now, if they ask some C or all C being A is a possibility, what you will write? What will be the answer? Definitely there cannot be a possibility because there is no relationship between A and C. First of all, there is no relationship between A and C. Clearly there is, and also clearly they have given no B is C. A is inside B and no B is C. It is clearly given there is no relationship between B and C and A is inside B. So if they give some C or some A or some C or all C is being a part of A is a possibility, then it is definitely false. Okay, do you get this? Do you get this point? Some C or all C is being A is a possibility means it is definitely wrong because A is inside B and B is not in connection with C. For example, if A is, for example, let us consider if A is outside B or A is some part of B, then that that conclusion may come true because some part of A alone is inside B. But in this statement, every part of A, all part of A is inside B. So the conclusion, possibility conclusion fails. Okay, if some part of A alone is inside B, then there can be a relationship between A and C. And another one small point I have to say, if there is no relationship between some variables given in the question, then that will be also added in the possibility conditions. That will be true in possibility conditions. But in this case, since A is completely inside B, there is no relationship between A and C. And we cannot also say there is a possibility condition between A and C. Okay, clear? Okay, let's move to rule number 8. All A or B. Very easy. All A or inside B. So what are the conclusions for this possibility conclusions for this diagrammatic representation? All B being A is a possibility. Yes. Some B or not A is a possibility. Yes, it is also a possibility because only some part of B is inside A. Some part of B contains A. Some part of B is itself a B. So some B or not A is a possibility. It is true. Okay, it is very easy. Rule number 9. No A is B and no B is C. How you will be drawing? There is no relationship between A and B and there is no relationship between C and B. That is B and C. But the statement only it is given there is no relationship between A and B and no relationship between B and C. Nothing like A and C relationship is not given. So in the conclusion, we can say some C can be A because there is no relationship explicitly given in the statement between A and C. So we can say some C can be A is a possibility. So see here in the conclusion can be is written. So it is nothing but a possibility keyword. So you have to indirectly understand some C can be A. Yes, it is true. Some C can be A or all C can be A because there is no relationship between A and C. We can say, but it can be a possibility. It can be a possibility. Some C can be a. It is a possibility. So that is true. Okay, do you understand? Okay, let's move to next. Okay, now let's solve some examples. So have you been all clear with these rules? Now let's solve some examples. You will be very much clear if you solve this statement. Some beads or chairs, all chairs or desks, and all desks or tables. So some beads or chairs. Say in the conclusion, at least some tables or beads. So okay, I'll come with that next. Some desks or beads. These are the conclusion here. This will be the actual question. This is what the question is. Now you have to draw diagram based on the statement given, and from the conclusions you have to check whether the conclusion given is correct or wrong. So some beads or chairs. Some beads or chairs. All chairs or desks. All chairs or desks. And all desks or tables. All desks or tables. So, yeah. Okay. Conclusion 1. At least some tables or beads. So, at least keyword before some, in front of some, is nothing but some tables or beads. You just forget at least. It is just for confusing you. They will be giving. At least in front of some is nothing but a sum itself. Okay. So, we just can, if it is given at least before some, we just leave that, and some tables, we just read it as some tables or beads. So some tables or beads, yes, it is true. So some tables or beads. Some desks or beads. Where is desk? Some desks or beads, yes, some desks are inside beads. So some part of desks or beads. So both the conclusion follows. Okay. So do you understand this example 1? Okay, let's go to example number 2. The statement given is some beads or chairs, all chairs or desks, and no desks or tables. So the conclusions, what they are given means some tables or chairs and some tables can be beads. See, can be is given, it is a possibility conclusion. So let us draw a diagram. Some beads or chairs, all chairs or desks, and no desks or tables. So no relationship between desk and table. Some tables or chairs. Is there a relationship between table and chair? No. Since chair is inside desk and desk is not a relationship between with the table. So some tables or chairs does not follow. No, it is wrong. Some tables can be beads. See, from the question, you see there is no direct relationship between beads and tables, and also only some part of beads are inside desk. As I have already told you in that slide itself now, some part of beads are inside desks. So there can be a possible relationship between beads and tables. So some tables can be beads is follows. So it is true. Okay, do you get this point now? Yes. So this is, are you all clear with this example 2? Okay, let's go to example number 3. All goats are lions, no lion is tiger, and some tigers are horses. So conclusion given is some horses are goats and no horse is goat. So this type of conclusion also we have to know. See, in this conclusion, both the conclusion contains same variables, but only some and no is different. So it has same variables, horses or goats, and no horse is goat. If you have given with this type of variables and this type of conclusions, what you have to do, I'll say, me see. Let me draw an example first. Draw a diagram first, and then let's decide. Okay. All goats are lions. So you're drawing all goats and lions. No lion is tiger. No lion is tiger. And some tigers are horses. Some tigers are horses. So some horses or goats. In the conclusion is given some horses or goats. We can't say some. There is no relationship. First of all, there is no relationship between goats and tigers. So we can't decide. And in one case it is given no horse is goat. So see here, we can't decide anything from this. Okay. So what? So in such conditions, we have to see both the conclusions, whether the variables are same. See, in this conclusion, it is given horses, some horses or goats, and no horses goat. Both the conclusions, both the number 1 and number 2 conclusion contain the same variables, but only some and no is different. So if you are given with some such type of conclusions, then you have to answer it as either 1 or 2 follows. Either 1 or 2 follows. It is only possible if you are given with the same number, same type of variables. For example, if you are given the first conclusion is some horses or goats, and the second conclusion is no tiger is goat, then you can't say it is either 1 or 2 follows. Only the variables should be same in both the conclusions, with the same and with some and no keywords. Okay, then only this either 1 or 2 follows will be correct. Okay, so this type of question also you will be getting. Okay, I think you have understood this. Okay, let's move to example number 4. Some tents are houses, all houses are buildings, and some buildings are huts. So conclusion, some huts are definitely not houses, and some buildings are tents. So see the first conclusion, definitely, a new keyword called definitely is included. So what is the definitely? Definitely means if it is 100% correct, then we are going to say it is definite. If it is not, then we are going to say it is not. It doesn't follow. That's all. Like possibility, like how possibility we are saying, same definitely. Definitely means also if it is 100% correct, we are going to say it is definitely. Okay. So some huts are definitely not houses. So first of all, let's draw a diagram for this. Some tents are houses, all houses are buildings, and some buildings are huts. Now come to conclusion. Some huts are definitely not houses. Some huts are definitely not houses. So from the diagram itself, we know. We can say some huts are definitely not houses. Okay. So we can't say, we can't decide. Because some huts may be houses. And some huts may not be houses. So definitely we can't say. We are not 100%. We don't know whether it is correct or not. So we can't say. And some buildings are tents. Yes, some buildings are tents. So it is absolutely following. So definitely means if you are 100% sure about what it is given in the diagram, you have to give it as right. Otherwise, it doesn't follow. Okay. So that's all, friends. We have solved all examples, and also we have see what are the rules to be known for the syllogism. I think you have all understood this. Okay, if you have any doubts regarding the syllogism topic, you can follow our website bankaspirants.com, and also you can give your feedback and comments in our website. Thank you, friends. Let's see in next video.